Okay, so we will now continue recording our lesson from the by setting up, because the pyro simulations from the point of impact from the guns. So in the last video we created we cached this out. I'm gonna turn this off. We cached these points out, which was these basically particles hitting, and then as soon as they hit, they're exploding into millions of chunks. I guess some of these we can also use for instancing debris and glass pieces, which is not a bad idea. We should just keep that as an option, which I didn't do in the last scene. Okay, so now to begin our pyro settings, we should probably just create another geometry node here, and then we're gonna call it shape a pyro impact. So this is gonna be kind of like a automated way of spawning pyro simulations. So what we're gonna do is now we need to understand that we cannot simulate an entire environment and expect it to look good every time there's an impact happening. This could be very, very difficult to manage. So as you can see, there's a lot of impact, so we cannot really have a ginormous simulation bounding box. So there is a tool actually for this that kind of does something similar, pyro cluster and smoke cluster. It's gonna do what we're gonna do now, but I kind of want to make it myself, like a little bit of a custom way to do it, to show you actually what's the logic behind can be. So what I want to do now is that I know that I cached out each of these gun simulation is, I cached it out for 500 frames from 100 to 600. So I want to spawn each of my caches in one frame to see how like a ghost trail looks, right? So I'm going to create an add swap here, and then I'm going to create, I think I can say it here, I want to create 500 of these. So it's going to give me 500 points like this. No, I don't want it like this. That's rather cumbersome. I can just make 1 point and then copy it 500 times. Okay, so if I put a 500 here, I should get 500 points. Okay, so now I want to load, basically I want to use my point number as a frame number, so I can load each one of these caches I cached out to disk per frame into one frame. So I'm going to create an attribute wrangle. I'm going to name this load hits. Okay, so as at instance bullets equals sprintf. That's for loading, squeezing in attributes into strings, right? And I wrote my path. My path was here in the previous sim, and then what I want, in case we have a little gap, let's first refresh our memory and what that means. I'm gonna bring the file browser here. So that's where we wrote up the caches. So media, Trice-Gold, this is my storage space for quick turnaround. This is obviously, you will replace this with yours. And then now I want to change that to basically I want to override this number with the point number. So now, because I'm using the sprintf function, here I can write %, 04 is for padding, s, and .bgo.sc, close parentheses, and now comma. I can actually, I think it's easier to write it here so you can see it better. So now here I'm going to say, instead of like replace the %, with point number. But there is one thing that we need to be cautious about here, is that simulation time versus frame time doesn't actually necessarily overlap. So loading everything at by default will not give us the proper range because we are using $F for loading the frames. However, I'm gonna put this on manual. In our ship frames, start frame is 100, so we need to put a little offset of 100 frames in order to, I believe, load the correct frames. Plus 100. Now this should give us the correct, well, it's not here obviously, but okay, so we can do it here. Let me see if that took it. Okay, we are on manual. Let's bring it back up, and now I'm going to actually load this caches now. So I'm going to use the instance swap. I use this workflow quite a lot. I mean, most of this can be done in a lot of different ways. I just like to stay as independent as possible from the software side of things. So I keep loading things from outside as opposed to maybe caching them inside or keeping it live, which would generally slow us down. Okay, so here our custom attribute is called instance bullets. So let's copy this and paste it here. So this should now give us, let it cook for a second. So it's gonna give us like a, it disappeared because I tried to fit in the screen. Okay, maybe our maximum clip is too low. Okay, let's get this one. Let's keep this maybe 100,000. This is something to do with your graphic card settings. Okay, so now what I get is a ghost image of every frame loaded in one frame, right? So it's everything is overlapping. So remember we had a but basically, I guess before continuing anything, we can say instance bullets. Okay, so let's categorize this section as load bullets. Okay, and now what I need to do is I need to unpack them because I need the information from them, and also I don't need anything that travels, but I only need anything that actually impacts. And remember, we also created a group for that, which was called boom group. So if I just keep the boom group, keep impact only, now it's gonna give us only the points that are created because of an impact. Okay, so what I need to do after that is that I'm going to create a partition out of this, but the problem with it is that right now we have, so the cluster points node works on checking distances from one point to another, but we already have a clustered look within themselves, so I don't need to actually search through 3.7 million points. What I can do is that I can actually group range, maybe I can say keep, and then I can say I only need 10% of these points. Okay, so I can say 10%, so that's gonna give me a group called keep, which is 10% of the total number of boom group, and then I can blast everything else. Keep, blast everything else. So kind of like 3.7 million, 372, and now that's gonna work a lot faster. It's just a little optimization, so we can even like measure that. So it's gonna create by default 10 cluster groups based on the connectivity, and kind of colors them as well. So this one took 5.9 seconds, and now if I stop it and then probably go here and do it again, and I need to record it. Okay, so let it cook. It should take a lot longer because it's gonna loop through like a lot more points, but in the end it's gonna give us the the boom group. Little mistake there. Here, let it cook. But since the overall shape doesn't change, it's just like little, optimization tricks that I see that occasionally that are not considered during the production, that little things like this can actually speed your workflow up quite a lot. So I strongly suggest keeping a very open mind for optimization, which can significantly improve your workflow and your output. And you'll see that the overall, I'm gonna wait for this to finish, and you'll see that the overall output is gonna be exactly the same, although with less points. And then maybe if we need, from our optimized version, we can always do an attribute transfer to our high-res version, which in this case won't be necessary, however. Just a little bit more. Okay, so that took 56 seconds, and it's the same thing, and this took where is it? 5 seconds. It's almost 10 times, and output will be exactly the same, almost same. So what we can do now is that I have 10 groups, which means that each impact now is each impact can be automatically separated by using a cluster ID. So I can focus on my bounding boxes in closer sections, which we are gonna stick with. So after this, now what I can do is, because this is like a single frame thing, so what I want to do is to actually cache this out as a single frame, which is called, for that we can drop in a file cache, rename it to file or cluster groups, okay, and we're going to probably use a path. I'm gonna copy paste it, it's up to you. I am putting it under geo pyro cluster IDs points.bgo sc, load from disk, save to disk. Okay, so now anything above won't be calculated, which we don't need anymore. So now we can group this as well. Cluster creation. Okay, we can name this guy cluster creation. Okay, so moving forward down, now we need to create our sources. But so the problem is I have frozen sections, but I don't actually have moving source. So how do I now create how do I capture my moving points using these points? So first thing I need to do is to actually isolate my cluster points. So I can drop in an attribute wrangle, and which is also going to be our wedging tool here. So we're going to call it keep wedge. I'm going to create a little using the gearbox here. I'm going to create an integer attribute that I can link something. I'm going to call it keep, apply, accept, and now I'm going to type a little expression here again. If I at cluster is not equal to my slider here, remove every other point from the scene. Okay, so that should just give me 0. Remove point. There's a little typo here. So that this is now declared as apparently it's the cluster 0. So now I need the moving versions out of this. So how do I do that? There's a neat trick we're going to use, which is using an Vex function called find attribute value. So we need to now load in our moving cache, which we saved out to here or wherever you've saved it out from your bullets. So let's call this bullets. Okay, and now drop in another attribute wrangle. So what we want, so basically what we want is to loop through the left side, which are our moving bullets, So here, for example. Okay, and then find our keep wedge points against the look against the keep wedge points and do an ID match using this. So match keep moving, or let's say keep load moving. That's actually keeping it, but never mind. So in order to do that, what we need to do is we need to first, I'm going to declare the material so you can see the sign. I'm going to create an integer called match, and then I'm going to say find attribute, find attribute val, no, attribute val from the second input on the point context. Look for the ID attribute against my current ID attribute. Okay, so that's going to return some numbers. If it finds match, it's going to return an incremental match value. If it doesn't, it's going to say I couldn't find this particle, it's -1. So now then I can also use, again, I can say this time if I at match equals -1, if it's equals to -1, then remove it as well. Okay, so here now it's gonna get rid of the points that are not moving, but it's just gonna load the points that are moving. So all of these points are actually created upon impact. Everything else is bouncing points, or that belongs to a different different seed, different wedge. Okay, so now what I can do is that also, I'm actually now ready to create my pyro source. So here now I can create another attribute wrangle because I want to drive my certain values by age, particle scale, for example. So I'm going to type here age to size. Okay, so we're gonna type now add p scale fit. So I want to get the age, I want to fit my age because I want the particle is at age 0 when it's born, but what I want to drive is the reverse value of that to be fit into a value. So because like our particles were living 0 to 4, that their maximum life was 4. So I'm saying this is my input, but I want my output to be 1 to 0. So it kind of refits all the values to so when the particle is born, its size is 1, and then when it dies, its size is 0. So this way we can fade off the density and the temperature and whatsoever. Okay, so then I want, because I was quite happy with the colors initially here, because they show like a proper impact. Maybe here, can load them. So I want the colors to drive the heat as well. So now here I can say a temperature equals luminance. It's gonna give you the luminance value of a vector, and then CD. So it's gonna turn this into a nice value. So the other thing that I want to make sure that is that not to have incredibly fast particles, which are we can actually see them here. I think upon the very first impact we get some really fast, but let's it's almost like just the particles before they arrive. So I want to get rid of them as well because they can create unstable results. So then I want to measure, I want to do that by measuring the speed of particle, which I can use length at v, which velocity is, let's say, bigger than 100 meters per second. I don't need them in my volume source. Okay, so that kind of removes it maybe a bit too much. Let's try 200, just to make sure that I'm in the ballpark. Probably 250 is the value then. Okay, so let's scrub a little bit. Still get some more. I want to get rid of those. Let's put a 200. Okay, I think that's the good number. Okay, so now finally I can create a pyro source. I prepared my materials to be ready to do the points are ready now to do the to supply enough good information for the pyro source. So we can keep it as source fuel, particle separation. We cannot keep this as regular. And now what we can do is to create plus. Actually, yes, probably that's what we can do. So if you create a pyro source by default, I think you can change this to source smoke, and it's going to change the settings. But I guess we can then change it to source fuel, and it's going to load. It's going to load basically like a presets of what you need. So what I'm doing here is I just changed some of these values to 0.75 because they were working a bit better. But then, in order for us to see that it's actually working, we need to bring in a volume. We need to bring in a volume rasterize attributes. Volume rasterize attributes here. And if I plug it in and then change it to what I need to read, which is temperature, fuel, and velocity pretty much, then it should create me some values here. Okay, so if I have, I'm gonna use the normalized clamped coverage. It's kind of like, it creates a bit more normalized version here. It just says, as it says, enabling this option multiplies the sampled volume by coverage, yielding a smooth transition between areas covered by the particle. So here I want to play with some of the settings. First of all, my voxel size is probably too small for speedy scrubbing. So this is for testing the quality, which we can change after. So I want to drop my particle scale to 0.2. Okay, and then now we can turn on the velocity motion blur because we do have these settings. So if you look here, it's some more samples. We're gonna get some more fall off. Okay, and I think at the moment this is probably good enough. But then we need to basically play with these to do our test simulation, and once we're happy, we will move forward with the different settings. I think for now this is fine, so we can say null, put a null here, and then we can say bake source. Okay, so let's stick with this simulation to make our first sim. So the other thing we're going to need now is, because we have so many simulations, so many random simulations we're going to have, but we don't know when to start this simulation. So now what we need to do is, after we mark this section, the prepare source, let's call it prepare source, prepare source, and these are keep wedge. This is important. We're going to connect this to something. Okay, so that's also important because it's going to go inside the sim. Well, actually a file load will go inside the sim. We're going to cache that out. So now what we can do is to actually drop in a pyrosop. So dot network. Let's name it bullet pyro. Okay, so we can dive inside. We're gonna drop in a pyro solver. Okay, and then we're gonna put in a smoke object, and then we're going to put a gas fluid dynamic resize for the pre-solve, and then finally we're gonna get a volume source. So we have the basics now to do our simulation before adding our collision mesh. So in our smoke object, what I want to do is to define the bounding box from the first frame of the source. So let's find out when is our first frame here. So our first frame is 351. So basically we had to find a way to get frame 351 into our start frame. Let me first just add, we also need to get the proper size and dimension so that the solver knows where to create the bounding box. So for that, like I said, we can lock the parameters of the smoke object and then get the size information from the bake source. So for that we can use the bbox expression, and then we type in the address of our source, and then we need to fetch the X size. So as you can see in the help, it's X size. So then all you have to do is to copy, paste Y size, copy paste Z size. This first frame is a bit small. I'm suspicious if that's gonna work fine, but we'll see. So then in the center, this time from bbox, we change the expression to centroid, and then instead of the X size, it's gonna use just the X, dy, and dz. So we just copy paste and repeat the same things. dy and dz. Okay, so that should give us the proper size of this, but now we still don't have access to our start frame, and that's how we're gonna solve this, is by going through our cluster setup. So what I need now is another keep wedge, and I think we don't even need to cache this out, because I mean I was originally caching the source, but honestly it's actually updating quite fast, so we probably don't need to do that. So we can straight ahead cache the information, get the information from here, because originally, okay, so if you end up getting a very heavy, if it takes more than let's say a second to create the source, you need to then maybe cache out your source file, but it's for the sake of the simulation, it's probably not necessary because it's already loading quite fast. So I'm not going to pre-cache the source, but you can if you want. So what I'm gonna do instead is I'm gonna create another branch here. So right now in every point, as you can see, I have my hit attribute, which I turned on, hit time, sorry, which I turned on in the popnet. So this one ranges from 10.44 to 14.53. So basically the 10.44 should be the very first particle, if I visualize here, and that is the case. So this is my frame, but then I remove some of these. So from here is the particle that I can find my first impact frame, okay, which means I can then create the smallest number is going to be converted into my start frame. So I can do an attribute promote here, okay, I can go here, then I can say promote hit time from original to detail, sorry, but only get the minimum because I need the minimum to be able to start my sim. And then I'm gonna create a little attribute wrangle here again, and here I'm gonna say dop start time or frame, dop start frame, and then here then I'm gonna run it on detail. I can write this expression pyro start equals f at hit time, because it's seconds times 24, and then I need to put my frame offset plus 100 because this is loading. This is is equals, but that's an integer. 100 is because our hit time is actually the frame number. Which reminds me, we may have made a mistake somewhere here. I don't think we need to offset. No, this is fine. That's different. Okay, it's because our frame number starts from 100 and our point number starts from 0. That's fine. That's another offset. But here is because our dopnets of the bullets starts from 100. So actually the hit time 0 is equal to frame number 100 because dop networks has their different time range than what's outside. Okay, so that should give us a proper number, although we need to convert that to integer. And now this should give us, we have a little error here somewhere. We forgot one more parenthesis. Okay. So we can now color this guy since it's an output as well. And now we can fetch the start time, the expression from dot start frame. That should work in using the detail, and that should be dot start frame pyro start. Okay, that should plug in the correct time, and it doesn't. It didn't. Why? Detail dot start frame. That should actually, let's check first if our yes. So that's, it should fetch 350. Oh, it does. Okay, so it's working. So we just need to go back one frame. Put on auto. It's trying to load something. It may have crashed it. No. It's erroring somewhere. No, okay, so it's the bullets. So if it finds empty, maybe we need to just change that to no geometry so it doesn't error. And this should turn into 350, but it is calculating something. So it is not returning 350, so that's not good. It's returning 100. But our value is okay, it's 100 here as well. F at hit, because our hit time is 0. Oh yes, that makes sense, because this is the part we cannot use, and that's because in certain frames we are deleting the points, so it's unable to find points, so it's returning an error. So we're gonna hook it up to here to get our minimum value, which is always going to return the correct frame number, which is going to give us the proper start frame. So which we need to now double check that if we have anything in 3 frame 250, we don't, but we have in 1. So maybe we should give it a 2 frame buffer in case. So let's go 2. It's gonna set start frame 252. Okay, so now we can go inside, and if I press play, it disappeared. I guess didn't get enough density. So the other thing we can do is we can make sure that we're tracking. We can change the padding to 1 meter. We're tracking our fuel source. So because we didn't plug in our source as well. Okay, so go into the gas resize. So let's call this auto resize. Okay, in our auto resize, turn on the track by object, and then I'm going to load in my source. So it's gonna follow the it's gonna make sure that it's not smaller than the source itself. And then under the volume source, which is the same, actually we're going to select bake source, and we're going to load in our source here, and we can change our initialize to source field, which is going to create automatically what is needed. So let me see what happens now if I press play, and now it creates the simulation. It starts simulating. Our resolution is obviously a bit too high. Maybe let's go 1 for now, for speed's sake. Okay, so our auto resize is not working at the moment. That's something we need to look into. Max bounce, turn the clamp to max bounce, and if I press play, now it should be working fine. Okay, so this is working. That's good. Although the shapes and everything, which we're gonna work on. So now the other thing I want to make sure that I have, obviously, is my collision object. So for this, we can just go back into our particle simulation that we defined in the ship A guns. Just dive into your Gatling laser and copy this section. Back into the ship A pyro impact, paste, and let's drop in another merge here. Left FX right. Okay, so now we have our collision shape as well. So now we just have to make them look good, which means if I press auto, simulate a few frames, this happens. If it happens, it happens. I'm on Linux. I don't know why it's happening. Sometimes it happens, sometimes it doesn't. All I have to do is pretty much this. Probably should report a bug, if not anybody already. So if I press play now again, I'm gonna get some smoke spreading around the explosion area. Obviously, it feels like the velocity is maybe a bit too much. So what I need to do then also is to, instead of using density, because we create everything by default, I'm going to switch the visualization to multi-field from the smoke object. Under the smoke object, smoke density field, I'm going to type density. So my density to be calculated, the visibility of my density to be calculated from the density. And I can drag the colors a little bit with that as well. And then under emission, I can select heat and temperature as my color field. We can there is not really a definite answer for that, but this is how I usually use it. So now obviously we have a lot of mushrooms that we don't want, so we need to fix those. Let's start playing by some settings. Let's save our scene first. It's called Impact Pyro 1 HIP LC. Okay, and now if we go down, we can select the Pyro solver, and under the simulation settings, I'm going to change the cooling rate to 0.8. Again, all these settings is going to vary based on your input. I change the temperature diffusion to 2. I want harsh broken edges, not so soft field transition from hot to cold. So I'm going to change the gas release to 4 because these are only bullet impacts and not really explosions. I don't want it to expand so much. Flames to 10. Smoke, yes. And I want like a lot of smoke. Well, maybe not a lot of smoke. And then we can change the I change the gas flame contribution to 339, and then why did I change it to 339? Because I want the flames to be contributing to burn a bit more. Then again, these settings are all trial and error. Exactly, I usually find myself doing completely random stuff almost every in between every sim. So we can go into the shape, just experiment with these values. Dissipation is fine. I think I could go less, probably depends. I'm gonna have disturbance of 2. If I go to disturbance field, sorry, in the dissipation first, I am changing my control range to 0 to 3. Okay, and then go into the shape, and under disturbance, switch to this is going to be velocity, or turn on your control field. I'm going to change it to temperature, and I want a control influence of control influence to be 2, and then control range to be 0.5. Cut out, I don't want it to cut out so easily, so I'm going to decrease the cutoff range a bit more. And now I'm going to turn off the turbulence. I'm going to put it to 1, and then under turbulence I want a swirl size of 5. I think that was my value. Pulse length of 2, so it doesn't change so often. I want it to be a bit more granular, so it breaks up. We can add another level of turbulence. So now if we have a look at frame 371 versus, which there's a tool that I don't use very often, but if you go to the memory toolbar from the perspective, so if you click on this button, you can go to the memory toolbar, and then we can make a snapshot of this view. I think it's this one, snapshot. And then if I go back and go to 371 again, frame 300, if I stop at 371, go back to 371, and then I can compare from my viewport what has changed. And now I have a lot more broken up shapes, like if you look here versus if you look here. So this is a good way to use this tool to create nicer simulations. So if I keep press play, I would say I still need some more breakup, or maybe I still have a lot. Actually, I'm creating a lot of mushrooms, so probably gonna decrease my velocity to even lesser amount. So let's press play. It's slightly better. Yes, just need to probably break it up even more. So let's try that actually, which we can use the snapshot tool again. So let's go here to, I guess, this frame. I have a lot of soft areas. So I can do another snapshot. No, not like this, like this. So I record as one. So if I go back here now, what I can do is I can just play with these settings. Maybe my swirl size is too, or maybe my disturbance is too low. So let's go 0.4, let it cook. No, it doesn't cook. It would be nice if it did. Let's go to 372 if I load back. 387. So let's press play to go to 387. To see if it's gonna make a difference. It does, but very little. So I guess in that case we can probably maybe increase our turbulence scale with lesser disturbance. We can try creating a bigger control range to see if it's actually gonna make a bit more difference. Okay, I'm just gonna press play. No, that actually made it worse, I think. 387. Not much of a change. No, let's go 0.5. Let's try 5 to see if my disturbance is actually working properly. I think it's a lot more broken now. It's a lot more broken for sure. 387. Okay, so we need to find a bit of a nicer disturbance value because this might end up in becoming too noisy. So I'm gonna try 2.5 because that's more visible with the actually when you go higher res. So I need to find a nice balance between where we want to use disturbance as opposed to turbulence. But I think this is pretty okay. Okay, we have a lot more broken shapes now. That should result in good detail. Once we have a high-res sim, which we can just kind of try it out. Now if we go 0.25, I guess that's gonna be a little too slow for the tutorial, but we can see what it results into before moving forward, because that's gonna be our general quality for our latest render. That's a bit too slow. I mean, the shading feels off, but I can see that there's a lot of detail already. Okay, let's try 0.5 because that's really slow. Okay, this does really have a lot of detail. Alright, this it will, but what we want is probably not that color, which we can play here. I guess we can introduce more heat, probably a bit more orange. Okay. And I guess we can have, we don't need really a lot of white smoke, but just, yeah, go have some range, but I think this is a bit more in line. Okay, that's, so the other thing is now I noticed that since these are just bullet hits, we are actually making a lot of fuel and fire. So I'm gonna put that back to 1 because we're gonna have our explosions every now and then, but that depends. So basically, if you think it's too explosive, the way it looks, just, you know, dial down your fuel, which we can do now here. If I go 0.5 and 0.5 and press play, it would end up in less explosive look, more smoky look. And then you can also change the gas released to get a bit less explosive areas. But overall, that's kind of what you're gonna get. Let it cook for a bit more. Okay, so if I press play now, actually that's pretty cool. So imagine having several of these going poof, poof, poof all around the city. That's actually gonna look pretty cool. And then we are only calculating a certain area, so we can optimize it as much as possible. I think we can bring down the counts a bit more or less to optimize it a bit more. I think that's gonna work quite fine. Okay, so since now we know that it works with this seed, let's try another seed by changing our wedge. And then we need to find where we have those frames in this sim by, I guess we can load the load moving, and as soon as we have some frames, okay, so as soon as we see some particles, okay, this is our particles, and this is our first impact. No, it's our second impact. And where is this happening? So we just need to try it in a few other sections to make sure that this is working. So this is the bullets that just goes through, I guess. They hit this building here. So, which means at that frame, our start frame should be updated to 191. Is that accurate? Yes, it is accurate. Okay, so which means we can dive in here and see what it does in our simulation. And if it kind of works fine, it works fine. Goes through some holes of our buildings. That's due to our collision shape. And we have another automated explosion, which is working fine. If we look through this camera, do we see it? We fly by it. So if we go poof, 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 poof. Oh, that's actually pretty cool. Okay, so this might need a bit more resolution. Okay, so it looks like it's working. I'm just gonna try one more. Using our H to size, just gonna change the value somewhere. Let's go height. And let's check on the, so this starts at 11, maybe another one. That's very early, let's check this one. Which starts at 1.6 somewhere here, 141. I think that's the first hit, yes. That's the first hit. What does it return for start? 142, let's go to 142. Okay, so that's pretty reasonable number. So if we go inside and press play, we should get our ground impact, just working fine as intended. Okay, so it looks like this is working, which means now we can prepare our top network to automate the simulation. So for that, let's create another top network, and we're gonna create bake pyro from hits. We're gonna name it like this. Dive inside. Before that, we forgot something. We need to fetch that information out. So dop import fields. Out pyro hits. So we can drag and drop the bullet pyro to dop network, lock it, and then go inside smoke object to dop node. Presets can be changed to pyro. Okay, so a few things. We are not, the tutorial itself is not explaining a lot of pyro workflows. So what I don't need is definitely not these rest fields, because I'm not using them. I'm not gonna use the heat field. I'm gonna use the temperature to color my volume. I don't want the CD, fuel, heat. So I'm just like keeping everything as simple as possible. And one other thing I want to do is to make sure that I have a reasonable size of the simulation. So for that reason, what I'm gonna do is I'm gonna play this, and then I'm gonna, so this is now fetching the information from here, right? So what I want to do is to make sure that I'm compressing, because I'm gonna have maybe many of these, and I want to optimize that. So I really need to make sure that I have a good volume size. So one thing I can do is I can half the velocity field's sample size. So right now it's, I mean, we will try to squeeze this as small as possible, because now it's small, but once we up the resolution, it's not going to be so small. So when we need to render 20, 30 of these, that's going to be a problem. So in order to achieve that, there are a few ways to compress volumes. There's also a volume compress node, and then it's also available here. And then we can also compress using masks, which is the right input, which means that just compress it around the certain areas that has some information. So what I want to do now is, after I import my field, I'm going to need a volume compress. I want to get rid of first any attributes that I don't need, which is the dop object and the detail attributes. All of this I don't need. That's called the super little, like it basically does nothing. It's well, 100 kilobytes, I guess. That's still something. Now what I want to do is I want to blur my density slightly. Volume blur, and that's gonna be density using the voxel radius, and I want to blur it by 2 voxels. So I get like from this to this, right? So I don't want to use that as a mask. My mask group is density, and by minimal, that's what I need. And then I want to compress. First, I want to resample my velocity field, volume resample. So I'm going to just fetch, in this case, it's not plugged in. Let's plug it in. I'm just gonna get the velocity field. Okay, and I want to change the resolution, to drop the resolution of the velocity field by half, which means from 115, now we are down to 58. Okay, so if I plug this now into the new volume node, compress node, now I'm gonna turn on my compression settings. So this is the part you need to be careful. Don't go so aggressive. Things might show up that doesn't in the render, that doesn't show up in the viewport, but this is for us to keep trying to find the proper number. So I'm gonna pull on a null here and say out pyro. So now, even though this is a small sim, if I look here, my raw output is 5.97 megabyte per frame. My latest output is 385 kilobyte per frame, and that's actually quite amazing in terms of how much memory you're gonna save by just doing a slide optimization. If it's, I barely think, in most situations, gonna actually make a huge difference. Just play with these volume settings. If it's too aggressive, just change them. So if I, simulate a bit more, here now it's 9 megabytes, here it's now 447 kilobytes, which is great. Okay, now this is ready for baking. So let's go into our top network. We're gonna create a wedge node. I'm gonna call it wedge sim. Now that's gonna override our pyro wedge node, which we named as, I believe, ship A. I'm gonna paste the wrong one. Ship A bullet pyro keep wedge, right? So we here, which is this guy, and then here my attribute name is $keep. So that's gonna change based on what I'm wedging from here. Target parameter, of course, now I need to go back here and find my target parameter. I can drag and drop this here, relative channel reference, but I need this actually, like this, just the direct path. And then I want to figure out how many numbers I need to wedge, which is coming from the cluster. So I have 10 clusters, which means I need to do 10 wedges, and I'm going to change my values from 0 to 9. Or actually, if I have a look here, that's going to give me the numbers. So it's 0 to 9. So 0 to 9 here, and then 10 wedges because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can export these guys as well. Okay, so just to check this very carefully. So that's only for wedging, right? That only changes the parameters. So I need to save this somewhere. So rope geometry output, pyro wedges, and here I can now say I want to cache out pyro, right? That was our node. Let's go back in here, out pyro, just to be double, triple, quadruple correct. And these caches will go to my other cache folder because these caches take space. So I don't save them to my NVMe, although I actually made them quite small. Still no need to take big space. So they're gonna go under my backup folder, caches, volume cache, from bullet, version 1, veg. And this attribute here is important, so you don't overwrite your caches. So it's called wedge index. So let me actually go, I'm gonna name this volume cache, maybe caches, so I don't overwrite on my old one. Tutorial from bullet, so tutorial pyro from bullet version 1. So, okay, so these are simulations. So I'm gonna click on initialize simulation. Oh, well, actually I don't need to do that probably because it's the scheduler who's gonna take care of that, because I need to do all frames in one batch anyway. So, well, in case you send this to farm, this needs to be on. However, what we can do in the ROP fetch is that I want to simulate all of these frames in one, or like each batch of wedge to be treated as a simulation, so it doesn't jump, so it doesn't try to simulate frame 100 and pre-roll to frame 100, etc. But I'm gonna double check this output anyway. So the other thing we can check is the scheduler. So the maximum CPUs to use on the scheduler is actually how Houdini starts and stops jobs. It has got nothing to do with the job itself. This one is created from the job parameters. So here I'm going to change it to CPU per task. It depends. If it's a too heavy sim, you can keep more or less simulations, but here I'm gonna limit my jobs to 30 threads, so I can have 2 for my daily things to do. So here, which means that if I say 5 CPUs per tasks, Houdini will try to run 6 simulations at a time. That depends on the simulations size. It might be too slow, too big, because pyro simulations do good multi-threading. So you probably want to keep that to something high. So if I say 10, it's going to run 3 simulations at a time. But what I'm going to do is I'm going to run all of them at once. So I want basically scheduler to just run single job at a time. So that's what it does. If you have some other dependencies in between, what you can do is that you can have overrides. So each node has an override, and then I can have a local scheduler override to make sure that this is also doing one job at a time. Now I'm gonna save, and just need to double check if this is actually properly linked. Wedge count 10, random seed is fine. Here this should change properly, and then just simulate for as much as it needs to, which we are, I think, gonna define here. So I do want, not that, I don't want that to be one frame, obviously. I want to simulate the whole thing, 0 to 600 for each simulation, but that's gonna change basically. It's gonna cache, but it's gonna cache empty because the .NET is not starting from that frame range. Okay, so turn this on as well, I guess. Save. I'm gonna kick this off to see if it throws in any errors. So this is how many frames it needs to write, but each job should be run one at a time. Task graph table. These although feels a bit too many. All frames in one, that's fine. First frame is ready. This should actually be fine. Okay, so I'm just gonna wait. It should be 1 and it should be just going, the number should go quick and then it should just switch to the next page, switch to the next page. So I can check this from my other scene. Anything writing here? Cooking. Okay, so it starts writing frames, so I can check my frames. It's cooking 2 at a time. Why are you cooking 2 at a time? It's supposed to be all frames in one batch. Single. Maybe that's the scheduler running at the same time, probably. Okay, so now let me find the folder to make sure that this is happening. Backup caches tutorial, pyro from bullet, yeah, wage. Okay, so it's writing wage 6. And actually it starts populating the disk with some increasing resolution, so I guess that's okay. So now I'm gonna let this cook, and once it's finished, we're gonna visualize our sim.